Good morning, everyone. My name is Khalid Moose. I'm in the Azure Compute team. I'm program manager. I'm joined with a couple of colleagues who will come on stage as well. Our session is to talk about Docker on Azure. I know I did a quick show of hands to distribute some surveys just before the session. So I would like to do just a couple to get an idea. It was a little tough to put this session just because we don't know how many people actually using Docker in production versus dev test versus people who are just new to the Docker ecosystem in general. So just quick show of hands. I know we did already on the enterprise, but if you are using Docker just for dev test and you're just trying it, how many people, just to get a sense? Okay, quite a few. And people who are just new, never used Docker or know what it is. Okay, so that's kind of the majority. That's good. By the way, for this session, that's not expected that you know Docker in advance. We're going to go through some basics, and then we're going to do some little more advanced stuff. So that's really the agenda of the session. Really, what I really would like you to come out from this session is, if you've never used Docker, I would like to make sure that you have enough tools and enough information to go out there and try it out and evaluate it for your deployments and applications to see if it suits your needs. And then the second, if you have been using Docker, we're going to show you on some of the kind of the best practices and how you can architect your existing application to take advantage of the containerization that is out there. Okay, so those are really the advantages. And the last, we're going to show you how you can, after you deploy your application infrastructure, how you can monitor it and debug it if things don't go as well as you're expecting to do. So that's really a brief, high-level agenda. So before we get started on Docker and the containers, I would like to talk a little bit about the isolation technology in general. Isolation technologies has been around for a while. You probably have used all of these, mostly VMs, virtual machines. They are parts of isolation technologies that existed for a while. You can consider processes and process groups are examples, as well as threads. They're considered isolation technologies. Now the question is, which of these should I use for my system when I'm building applications? Well, there are many factors to consider, but it all boils down to a couple of items. Number one is, how much isolation do you need? And number two is, how much density? So a lot of characteristics, but it really boils down to those two. You need to look at how much density in terms of how much can you squeeze in of the hardware and resources that you already have, and also how much isolation your application really requires. So if I put this in a perspective of just spectrum of isolation, this is not a diagram to scale, but just to give you an idea, threads, you can consider them there, and they are some kind of isolation. They have some kind of isolation, but probably pretty low. You look at processes, you get a little more, and then you go out of the spectrum until you get to containers and then virtual machines, where they are fully isolated. But of course, with more isolation comes a little more overhead, and then with less isolation, you have a little less more overhead. But it is really a spectrum and something that you have to evaluate. There isn't really one of these solutions that works for everything. So there is no silver bullets that just use containers and it's going to work for everything. But you have to evaluate for the applications and the systems you're trying to build. So virtual machines. Let's look at the stack on difference between virtual machines and containers, since really virtual machines are probably the closest kind of brother or sister to the containers. So if you look at virtual machines diagram on how it stacks up, you have a server, the actual host. You have the host OS running on top of that, and then you've got the hypervisor you're running, and then virtual machines with a full copy of the operating system running on top of the hypervisor, and then that manages the virtual machine. This should be very familiar to all of you. Now, when you go to the container land, you still have a server host. You still have the operating system, but now you don't have Hyper-V. You have this lightweight Docker daemon that is running on top, that is managing these containers on top. So the containers that runs your applications are running on this daemon that is providing you abstraction to the kernel of the operating system, the host that you're running. So the main difference is that you're not actually copying the full copy of the operating system that you're running on your container, but you're taking bits and pieces from the existing OS that you're already running on top of. So those are kind of the main difference between the two. With that comes a lot of advantages. You can bring down the deployment speed and provisioning of these containers from minutes for virtual machines to literally seconds. And we'll take a look at a couple of demos on how fast provisioning these Docker containers. And this is why a lot of people are excited about containers in general because of those advantages. As we go into the session, we will drill into these advantages in more details. So let's now take a look at the Docker ecosystem specifically. So a lot of people talk about containers, but it's actually a little more than containers. There is other pieces to consider. So in this diagram, just showing all kind of the big picture of how it actually works. So in the middle right there, you've got the host that is running this Docker daemon that I mentioned in the previous slide. And then that manages the containers and the ecosystem for you in that host. But you need probably a client that needs to connect to that host if you're going to be doing some large deployments and stuff like that to manage these containers and connect to them. And then you have the Docker Hub. And this is where a big piece of the puzzle, which is important, which is the images. So containers, think about them as kind of running machines or running processes. But the benefits comes from snapping these running virtual machines or containers into images that now become a permanent state that you can share either in your private repository or publicly on the Docker Hub. And we will show what Docker Hub is, and we'll show a little bit about how you actually run these containers, how they show up from the host. And then you've got some repo that I'm showing there as we'll start building our application. We're going to start using what we call a Docker file to automate the creation of these images. Because in building one image, manually, it's not a big deal if it's small. But as things grow, you probably want some kind of automation where you want to build these images in an automated fashion and in a process that is repeatable. So those are kind of the key pieces. As we go through the session, we will drill into each of those. So advantages, the premise is, we want fast speed, and then we want it to be portable. We talk about images. So basically, you snap an image from a container, and then you want to be able to move it from one platform to another, from on-prem to a cloud provider or any cloud provider. And that is really the benefits. And also the scale out and down. And that's where the speed comes into the picture. So as you provision, and we'll see in the sample later. So let's actually dig into it. So this is just kind of want to get some basics, but let's actually take a look at what containers, how do they look like. So I'll switch. So what I have here is, let's say you just want to get a host up and running in a couple of minutes. You're very new to this, and you just say, look, I want a Docker host running. How can I get started? Very simple. You go to azure.com, and then you go to Marketplace, and then you type Docker, and then you'll get a Docker on your Ubuntu server. You pick that. That will ask you to create a virtual machine. Once you click that, it will ask you for a couple of basic information, the name of the host. I will ask you to authenticate, username, password, or SSH key if you have that. And then the region, if it will have the default information, but if you want to change that, definitely you can change that. That's it. Once you do fill up a couple of information, you click Create. What happens behind the scenes, it will actually boot up a VM, and it will install Docker on it, Docker daemon that I mentioned in the previous slides. And now you have a fully functional Docker host, okay? And let me show you how it looks. So I have one already ready. So this is a Docker host running on Azure infrastructure, on Azure VM. So once you have that VM up and running, you can go inside and just type and show why the mouse doesn't. It's kind of weird. The keyboard is kind of locked, looks like. Okay. I think I lost connection, but I'll reconnect quickly. So what I'm doing is I'm SSHing to that VM running on Azure, and it's just asking me for username and password that I created when I created it from the marketplace that I showed earlier. So now I'm inside, and to take a look at the Docker CLI, you just type Docker. This gives you like all the commands that are supported by the Docker CLI. So let's actually do a container, create a container, just for the fun of it. So I'm going to do Docker run. So you do Docker run, and then I'll do run it, and then I'll say, let's say I want to provision a, Ubuntu Docker, just plain vanilla, OS, and then I'll say something like this. Oops. Looks like when I lost the connection, a few things happened, so I'm trying to reconnect a few things here. So the daemon wasn't running, it got shut down for some reason. So let's try this. So there is a command called run that will basically pull up the image that you specify, and then it will run a Docker container on it. So if I do su Docker run, and then it's basically just interactive and provide TTY. And then in this case, I want to remove that container once I'm done. So Ubuntu. So now I'm inside that container. Think about it as if I SSH into that machine. So what you have here is a container within that VM. That is, from the view, it will look like just like a full Ubuntu OS. So if I do ls, it's inside that. So let's actually play with it a little bit. Let's say I go and create a file. Let's just say Ignite txt file or something. And then I'll say I am testing my image or my container. And then I'll save that and exit. So now this container has that file that I just created, or I deployed an application just as an example. Now if I exit, I will lose everything. And then what I can do is I can go and do another container, and then I look here, and the file is gone because I have a whole another machine running. Okay. Now let's say I actually want that file, the application that I deployed. What you have to do is you have to commit. So let's do that. So I'm inside that container, another container, and then I'll do, vi something like, again, ignite, txt, and then I'll put something on it. Let's say testing my container, and then I'll save it, and then I exit. So now, again, in that machine, I have this file running. But so I'm going to go outside, the container, because the commands now I'm using through the Docker, CLI. So I have to go into the host to connect to it. So I'll try to log in here. For some reason, all my sessions that I had ready before the demo went down because of switch of the internet or something. So I have to log it back onto them. So yes, so I'm here trying to log in. Oops. All right, so it's supposed to be my trace log. Right. Okay, so if I now go back here, hopefully it will allow me to log in. So if I do su docker ps, then what I'll see is the containers that I'm running, and basically I'm just saying, show me all the containers that are running in this machine, and that this host is managing. Now, this is one of the containers that I was looking at, is this one. So if I pick the container ID and say su do docker commit, and then I give it the container ID, and then I give it an image name, and you can pick any name you like. So for this case, I'm just creating my private image. So I'll call it Ignite demo, and it will give me an image unique ID, which is this GUID. Now, what I can do is I can provision other containers based on this image. Okay? Now, this image can stay in my private repository. I can build on top of it other stuff. And then when I'm ready, I can share it with somebody else. And that somebody else can go and provision other containers on top of this image. So let's do that. So now I have this image. I can go back to, I can save the name. And then I can go back to the host and say, I'll exit from this container, and I'm inside the host again. And then I can do same command, but now I'm giving it my image that I just built, which is, I'll just copy here. Now the only difference is now that file should be there, because it will, oops, did I pick the wrong file? Should have stayed there when I created that. Maybe I picked the wrong container, the previous one that I deleted, but for some reason, let me try this. I think I picked the wrong one. So same thing. And then what commit does is just snapshot an image based on that. I already exited the container. Let's see. Docker. Okay. Okay. All right, so I don't want to spend too much time, but the idea is that you snapshot the changes that you had in the container, you commit them into the image, and then you can share that image. I need to move on just because of time, because we have a lot to cover. But that is the the idea. What I would like to also, once you actually have this image running, what you can do if you want to push it up to the repo in Docker Hub repo, basically you just call into the Docker push. So in this case, if I exit from this container and do Docker and then push, and then you give it the image name, and then ignites demo. And then what it does is it will package this image and then send it to the Docker Hub. Now, this image will be public. Now, you don't have to always publish it publicly, but you can have a private repo that is only managed by you and give access to others. So you have that flexibility. So the idea is you create a container, you do a bunch of stuff, you can snap an image, and then you can publish the image. That's really the high-level idea. So I'm not going to wait for it to push, but the bits will start going up. A typical image, about 200, 300 megs, will take about a minute or so. OK. All right, I'm switching back. So it's already pushing the bits, but let's move on. All right, so containers can run anywhere. What I've shown so far is Linux containers or containers running on a Linux VM. However, the Windows team is working on enabling the same functionality for Windows, so you'll have Windows containers. There was a deep dive session, I think on Wednesday, by Aaron and Taylor. So if you haven't been to that, you can go and watch it. We're not going to dig into a lot about the Windows containers. They're not available yet, but they show demos. The idea is we're using the same ecosystem, which is the Docker ecosystem, and the management interface to manage both the Linux and the Windows containers. So at the end of the day, it should look something like this. You'll have Linux containers and you'll have Windows containers, but you can manage them using the same Azure Docker CLI that I showed earlier. So the same API management on top of them to do what I've just done. So pushing an image or creating a container, same interface, but there will be a separate Windows containers in addition to the Linux containers. You can also connect these containers. They can talk to each other. So if you're building a multi-tier application and you prefer to have some database running on Windows, containers and other applications mid-tier running on a Linux container, you have the flexibility to do that, and those containers can talk to each other. So that's kind of the idea. So I'm not digging into the Windows in details, but just want to give you a sense that this is coming as well. So let's now actually, OK, great. This is some of the basics. OK, we create a container, we do an image. Let's actually see if we can build like a real-life application that we can actually deploy and see the power on how you can do this. So I'm going to invite Tom to the stage. And Tom, the dev, is going to show us how to do that.
Awesome. Thanks, guys. How's everybody doing today? Pretty good. How's build? Sorry, I'm just coming from build. I've been running around. How's Ignite going for you guys? Well, this is just turning on and make sure I have internet connectivity here. So what's the best deep dish place in Chicago? Because I tried about 7 in the last 3 days, and I have my personal opinion, but Gino's East is leading for me right now. All right, some thumbs up. Fantastic. Okay, so like Khaled said, we're going to actually take some of the primitives that he started to talk about and try to stand up our own full-fledged application here. And I'll walk you through some of the tooling that we support on Azure to do that. So to kick off, who's heard of Azure News? Anybody? That's because I made it up this morning and we actually haven't built it yet. But it's, so the screenshot is TBD. But essentially what we're going to be doing, who's heard of Hacker News? Anybody here? Yes. So it's pretty much the startup open source hosted news blog on Y Combinator's page. And today what we're going to do is build essentially the new page functionality of Hacker News. So this is just a screenshot from Hacker News. And if you look at the news stories, it's just sort of time ordered, the latest stuff. Today we are not going to look at any of the fancy upvoting and comments and points and things like that because we only have a few minutes. But here's the 10-second spec for what we're going to try to build today. So Azure News is going to show us up to the 30 most recent posts so that you guys can contribute. If anybody has a phone and has heard of text messaging, we will support that as an input method for the page. It's just a really simple couple of Node.js servers. So I have an Express web server that's going to serve the front Azure News homepage. I'm going to have a separate server that's set up to work with Twilio so that I can accept SMS messages from you guys and actually live post to the page. We've got a simple single, not HA, just very basic MongoDB container set up for persisting the stories. And we've got a local Redis cache just to show off that we can have a whole bunch of containers running at once. So to get started, the first thing that we need to do is to stand up a virtual machine that is a Docker host. And to do that, we have a couple of methods. Khaled showed you going through the marketplace entry vector. But there's also a tool, and when the links are shared out, there's a tool called Docker Machine. And Docker Machine is actually a project owned by the larger Docker organization that allows you to just spin up individual hosts all over the place. So they have drivers for all the major cloud providers, Azure, one that rhymes with AWS, and even things for like VirtualBox and things so that you can have a box locally. So we have a virtual machine. I've already set that one up. We'll have links to Docker Machine at the end of the presentation. And traditionally what we may have done is just stick all of the components of the application that we just talked about into a single VM image and just bake that image, right? And I've drawn this very purposefully because the different parts and different components, instead of thinking of it as one big black box, we can actually map each one of these individual components to a different Docker container in practice. And so in order to instantiate these 4 different containers, we're going to need 4 different source Docker images. And the way that we are sort of drawing the lines as to like what goes into a single container or single image versus the whole application is which of the parts are actually sort of functionally atomic. Which of the things can we spin up and spin down and scale independently of one another, such that we can scale without having to just multiply the entire set of resources across the board. And so the way the application works, in retrospect, I should have added one more line here. But if you look towards your right, the SMS container, that's going to field the entries from myself and hopefully you guys if you'd like to participate. All that thing is doing a little processing, making sure that there's no ugly links or sites or JavaScript that you guys are trying to be creative with in the crowd. We persisted up to our MongoDB container, which is running separately. And then I just have the web server is just pulling, we're caching the latest results. And when somebody asks to serve Azure News, the web server just serves it. And so what's cool about this architecture actually, and dividing it into the containers, is that it means that we can independently scale any of these elements. So if I want to go make duplicates of the data and run some analytics on top of it, I can scale out the database containers and let them sync. If I need more web server traffic because I'm getting so popular and my application's falling down, I can scale that independently of the rest of the app. And that's a really cool thing that for some of the IT folks in the room, we're also going to demonstrate as part of the application. So for this group of folks, how many folks in here actually consider themselves like developers versus the IT folks and IT pro? Oh, we got a good mix. How many think they're both? Because I've had to play both, and I'm like, yeah, okay, fantastic. So we will walk through a little bit of the code and show you some of the nice constructs Docker has for doing some more complex things than Khaled had just demonstrated. But the three takeaways I want to show in the demo today are A, having a method for consistent deployments, so having a really templatized, very deterministic way of defining my application and getting repeatable deployments. The ability to dynamically update segments of the application without taking the entire application offline. So that's one of the huge benefits of breaking things into containers. I can keep the majority or a small part of my app even always up and running while I take down other things and rev them and start up new containers in their place to build a new functionality. So we'll see a demo of that. And then scale, which everyone in here is aware of and is definitely a need in modern applications. The nice thing, as we pointed out in the diagram before, is with containers we have the ability to focus in on a really specific part of the service and just adjust the scale of that independent container. So before I jump into the code, the last thing is this is a high-level intro to a tool called Docker Compose. Docker Compose is one of the trifecta of tools that are largely called Docker's open orchestration APIs, along with Machine and another tool called Swarm, which we will not cover today. But Docker Machine's job, as we talked to you before, is to get me a Docker host up and running in the cloud that I can go start containers on. Docker Compose's job is to give me a way of using YAML to define what my application looks like and define the relationships between the individual containers so that we can stand up our application the same way every time. And that's the tool that we're going to spend the most time in here when we're looking at this demo. So to the Batmobile or console for these purposes, and we're on 7, right? All right. So there's Hacker News. If we hop into the terminal really quickly, so one of the nice things about Docker Machine is that it lets me manage all of my Docker hosts from sort of a single entry point. So if I just do Docker Machine ls, that'll list all the Docker hosts that I currently have up and running. So right here, I always have a dev box running locally that's running on VirtualBox on my Mac. And then Docker Ignite is the one that we're actively pointing to right now, and that's a host that's just standing up in Azure at the moment. And so if we take a quick look at what is currently running on the machine, we can do Docker Compose PS, and we'll see that nothing is actually up and running there. And that's not technically true. I do have some stuff running. But the cool thing is Docker Compose always gives you a localized view into your application. So because if we actually look at what's in this folder, you'll see that I have this Docker Compose YAML file. And so it will give me results back just in the scope of that particular YAML file. So even though there's other containers running on the box and there could be lots of other stuff going on, if I did an all-up Docker PS, so just Docker, not Docker Compose, I would see, hey, there's actually several containers running on the box. But with Docker Compose PS, I see just for the particular application that's defined in this YAML file, that there's nothing related to that currently up on the box. And so from our perspective, this application, independent of what else is happening in the host, my application has nothing running at the moment. And so let's take a quick peek at what a simple compose YAML file looks like. And you guys let me know if this is large enough for you. It looks pretty good. Okay, so let's walk through what this Docker Compose YAML file looks like. And this is for the application that we described for Azure News. So you'll see at a top level, we have 4 services defined. So we have something called DB, we have something called cache, we have our web server, and we have our SMS server. And each of those services has a bunch of properties that Docker Compose exposes that allows you to define like where's the source image that this container is being spun up from, what are my environment variables, how do I go build this, which other containers in my application should I have a direct access and direct piping to talk to the other containers. And so you'll see here that for the database, I'm just using a pre-canned MongoDB image that's up in the Docker Hub registry, passing in a couple of command line arguments, nothing fancy there. Same thing with the cache. Where it gets interesting is when we start building containers that have our own application-specific code in them. And so a great example of that is just what the web server looks like. So if we look at this configuration, in order to start up a web container, I'm going to build it from something called a Docker file that's located in the web directory. I'm also going to expose links to the cache container into the database container. So that means behind the scenes, instead of me having to do any sort of manual networking or keeping track of the IP addresses of the other containers, I can literally, from inside the web application code, I can literally just reference the other containers by using their container name. So I can say, in order to make the MongoDB connection string, I can just use DB instead of having to know where the IP address is. And that stuff all gets magically resolved by Docker and Docker Compose for you. And there's a couple of environment variables that we'll talk about later here. But essentially, if we drill a little deeper into this web thing, and we look at the Docker file that defines what the image looks like, this is a very simple but very common sort of type of Docker file. So we're starting from a base image called Node, which is basically just a vanilla Ubuntu image that has the Node tooling and NPM installed out of the box. Everything else is stripped out of the box. And then I have a couple of commands that essentially let me craft an image. Essentially, this allows me to automate what Khaled was trying to do manually by adding a particular file, capturing that, using it as a new image. So all I'm going to do here really is install the dependencies for the project, copy in a couple of folders, including my Node web server code and everything like that, and then define an entry point. And what entry point does is when the container actually starts up, this is the first command that's run. And in this case, all I want to do is container starts up, everything looks good, I just want to kick my server off and have it started. So following all those rules, we've defined the whole topology of our application here in the relationships between the containers. And once we have this YAML file, it's super, super easy to stand up. We use a command called docker compose up, and we'll just hit -D here to have it happen in the background. Otherwise, we'll get a crazy number of logs here. But by default, when I do compose up, it'll just look for the docker compose YAML file that's in the directory, and then if it can't find it, it'll throw an error. So we'll use the one we were just looking at. And you'll see that very, very quickly here, I'm spinning up the 4 containers that make up the application. So in that 3 or 4 seconds or whatever it was, I took the entire definition that was in that Docker Compose YAML file, and I spun it up, and now I have a live thing running. So a cool thing about Docker Compose, too, is that it gives me the ability to really quickly attach to the containers and take a look at what their logs are. So if I do Docker Compose logs in general, it'll spit out all the containers of everything that I just started up. So you'll see, if anyone's familiar with Redis, here's the nice ASCII art that they have there. You have the web guy already going out to the database and sort of prepping the cache and things like that. But the cool thing is that I can actually go in and attach to individual containers. So if I want to see what's going on in the actual SMS container, I can just attach to it based on the name that I defined in the Docker Compose file. So I can say Docker Compose logs SMS in this case. And here's just a live sort of look into what that server is actually seeing. And so if we go over to this nice messaging app here, I'm sorry, that's as far as I can blow it up, but I say hello Ignite, and I send that text to a number that I'll share with you briefly. That text goes through. You'll you'll see that it hit the SMS server here, and this is the sort of the logging that I have inside the SMS server. So from Waterbury, Connecticut area, where I'm from in Connecticut, my phone number is tied to the message hello ignite, and just the ID that's going into the MongoDB database. And if we go over to our actual web application, we will see that it's, all right, how did you guys find the number? Awesome. I got some IT pros in here, I guess. So you'll see that my message hello ignite updated here. Other people are sending in things. It may or may not be other folks who have already tested out this demo. But we're getting a live update, and our Azure News, Hacker News clone is live here. So right now we have a fully functional system from what we defined. But to take a look at the second takeaway that we wanted to do in terms of dynamic updates, I think it would be really cool if you look at Hacker News, all of these things are actually links. And so in this case, I just posted hello ignite, but there's nothing, it doesn't do anything here. And so if I'm opening up a text submission service, it would be cool if I could use like markdown syntax to submit links. And so what I want to be able to do is essentially take a link like this, google.com, and instead of having it show up as, let's wait for the refresh here. We just got google.com. There it is. Okay, sorry. So instead of having it show up like that, it'd be cool if I could add some functionality in the SMS web server that actually parsed that text, recognized that it was a link submission I was trying to do, and then had that represent separately in the actual web server. So what I can do is, in order to do this, I can keep Azure News up and the web server up, so you guys could keep looking at these awesome stories. And in the interim, just take down the SMS server, create some new functionality in it, rebuild that container, and it just plugs right back into the running application. So the way that I'll do that is we will kill the SMS server, and this is just docker compose kill, and we remove the old container. Yes, I'm sure. Now if we do docker compose ps, we'll see that we only have 3 containers running, so our SMS guy is dead. But the whole server's up. So if I just go and refresh this page live here, I'm still, people can come and visit the site. I'm still up from an application perspective, but the SMS, we're not currently receiving any new SMS inputs. And then what I can do is actually go into the code and write this really complicated new logic here that enables markdown link support. I can save that. And then all I want to do here is do docker compose build, and I'll rebuild the container based on the changes that I just made. Happens really quickly. So now I have a new image that I can start a container with a new functionality from. And then what I can do is restart just the SMS container. And in order to do that, you'll see a couple flags here that are just dressing, right? We still have the -d to make it happen in the background. But we also have this no recreate flag. And all the no recreate flag says is that when I'm using compose up and deploying the application again, if I have running containers that already match, things that are in the compose YAML, just let those count as like they're up already. And so in this case, we want to keep the database up. It's already running. We want to keep the server up. It's already running. All I want to do is restart the SMS server. So I do that. Spins it up in 2 or 3 seconds. So now we should have live support such that if I go in and this time paste in a real search engine, then we should see, there it is, Bing, and you'll notice that, hey, I've got the link here, and if I click this, it opens up, and so that link is live. So without taking the front end of our web application down, in about 5 seconds worth of work if I wasn't walking through the commands. I've uncommented the new functionality, rebuilt the Docker image, added new functionality, spun up a container in the context of the running application. Everything got magically hooked up by Docker, and people can start using the project. So if you guys want to play around with this a little bit, the SMS number is now publicly exposed. Please note that my messaging rates do still apply because I'm paying for this. But if you want to go and ping a couple of these, we'll keep this up, and if you try it on your phones, we should see some new messages coming in. Okay. So the last thing that we want to talk about. Oh, agreed. So I commented before about trying the 7 different Chicago pizza places. There's a reason for that, and Beard Groom. Who's the Beard brand fan actually? Come on, somebody did it. I do use Beard brand, and I think they're fantastic. So thanks for participating here. Looks like somebody found a hole in my parsing logic. Thank you for pointing that out. So the last thing that we want to talk about is scale actually, and scaling is also really easy with Docker Compose. So what I can do here is let's take a look at what. So the thing that I alluded to before, where there's stuff actually running on the box, if we just do a Docker PS and not a Docker Compose PS to see everything that's running on the box, you'll notice that there's actually a thing called LB, which suspiciously looks like load balancer, and really what it is just an Nginx container, another Docker container, sitting in front, listening on port 80 and forwarding traffic to my web server. And so if we go and look at what the Nginx config looks like right now, we'll see that basically there's one server listed, and this is the container that we currently have spun up as the web container. So it's going to that address and forwarding all the traffic there. If we wanted to do something like test how the web server is doing, we can run a simple Apache bench test against it, or not. Let's drop that down. And we'll get a printout that says, hey, like all the requests were served actually, and we did something like 467. We run a couple of these in a row here just to get an idea, because with internet connectivity, it's all over the place. But we're looking at somewhere between 350-ish and 450-ish in terms of number of requests. And if I wanted to say, actually, I want to go scale my capacity on the web, I can do Docker Compose, scale. I can use the name of the service, and I can just tell it the number of container instances I want to run. So in this case, I'm going to go from 1 to 2. So when I do this, it goes and uses the same starting image, spins up a new web container. Now we're there, and so if I do Docker Compose PS, we'll actually see that there are Web 1 and Web 2 servers up. So I've scaled it up to 2. Docker's done the work of assigning a new port and simulating that the container is actually listening on the same logical 3000 port. And what's cool is just by doing this and setting up some of the stuff on the box, if I go and look at the Nginx config, we'll see that when the new Docker service started, it was actually registered with a service discovery service that I have running on the box, went through and using templates actually updated the Nginx config, restarted it, and now with one command I've essentially doubled the number of web servers sitting behind the load balancer. The way that the service discovery works, if any of you guys are interested, is that I'm using a tool called Console. I don't know if anybody's heard of HashiCorp, but they did things like Vagrant and Terraform and things like that. Really cool company. But Console is a service discovery, distributed service discovery service designed specifically for working with Docker containers. So on my box is one of those things when I showed, hey, there's actually some stuff kind of running on the box already. We already had a Console container up and running. Whenever it basically listens listens to the Docker daemon, and whenever a new Docker container starts, we get notified of that and then kick off some stuff like updating the Nginx template and things like that. So it just happens seamlessly. So with that, we have the three main takeaways that we were going to have for that demo. And there it is. So we switch back to the slide inputs. It's 5, right? Awesome. So that was the text message. I'll leave that up for a little while. I do get charged for every text message, so craft some 1 or 2 cool messages, and that's probably enough contribution from you guys. And then, so the summary, we deployed quickly and in a repeatable fashion using the Docker Compose YAML files. We made changes on the fly while the rest of the application was up, and we added the SMS support for parsing markdown links. And we showed some simple ability to scale. And even though under the covers for this demo, we just did it on 1 Docker host, you could easily go out and extend it to multiple hosts such that you were spreading it out and getting some more effect from the load balancing. So I think that's my part of the talk. Thank you guys for listening. I'll bring Khaled back up here. Thanks.
Thank you, Tom. So this is a great app. Now, imagine how you want to take this app to, let's say, your test environments after the developer has developed it and it's working. You want to go and test it, and then from the test environment, take it to a production environment. So we want to take advantage of the great new feature that we introduced in IIS v2, the Azure Resource Manager. There's a deep dive session that Drew McDonald's and Mahesh has given, I think, on Tuesday or Wednesday. Please go and watch it. I'm not going to go into details on that here, but just give you an idea if you haven't gone through the Azure Resource Manager. Basically, you group in a bunch of resources together and then deploy them as one thing. And then you can, you basically define your application as a manifest that you can deploy through the platform. So that's kind of the idea. And so as Tom mentioned, he built the multi-tier application using the YAML file. You can take that YAML file and actually extend it to our ARM templates. So you can see the highlights there for an example, YAML file for using Compose, and then you can just plug that into your 1 or multiple VMs, and then deploy that JSON all up, and then you'll get the multi-tier application deployed for you on Azure VMs. So that's really kind of the idea. So let's actually show you quickly on how you can do that in on Azure. So if you go and just go to the portal. Switch there. So need to log in. Okay. All right. So if I go to Azure portal. I'm going to skip this and if you just go to azure.com, you go to features, and then you go to virtual machine. And over here, you will see a link to how to deploy VM resource group. This supports a lot of other components and technologies, but you can go and pick a template you're looking for. So in this case, I'm looking for Docker. And this to get you started, you can pick a Docker template to start with. So I'll pick this one, basically provision a Compose on an Azure VM. This will take you to a couple of options you can deploy. You can use the portal directly, so you just go and click deploy to Azure, or you can on the bottom pick up the CLI command, and then you just copy that, take it to your Azure CLI. So I'm my connectivity was lost earlier, so I'll just go and see if I can get my Docker run. We assess KM, CLI test. So I'm actually running Azure CLI as a Docker container as well. So I'm inside here. If I just type Azure, I should get the Azure CLI help. and then I can just copy-paste that command that I copied from the site. Now, because everything that you deploy will be deployed in a resource group, so I just went ahead and created a resource group before the session. So I can go and take a look at the ones that I already have deployed. So Azure group list, this will give me all the ones available. Then I will copy that command and give it one of the resource groups that I want to deploy to, and the deployment unique name. So I'll go here, copy it, and paste it here. And then all I have to do is change the resource group. And I want to deploy to the Ignite 15. So Ignite 15. And then I give it a name. That's called my deployment, demo Ignite 15. That's it. Now, the template has the concept, without a lot of details, concepts of parameters that you can define on the fly, because you don't want to necessarily hard code everything. You may want to make some parameters, defined by the user because they are specific, like username and password, and that's exactly what I did in this particular, template. Then you'll just go and enter some basic information. I'll give it like a storage account, username, and then DNS name if you want flexibility there. There is all kind of flexibility. By default, you get that simple templates, but you can, customize it to your needs. By the way, you don't have to use that sample as is. Most likely, you're going to take a copy of it, and then you're going to extend it, add more stuff that is specific to your deployments. So I can give this a name, Ignite, let's see, storage. So I don't know, something like this, and then use the name. And then I give it some password, something, $, something. And then I give it a DNS name. So Ignite DNS 11. And then the deployment will start happening. So at the end, what will actually happen, it will deploy the VM or multiple VMs, if that's what you want. It will put the composed file, that example like Tom showed in the previous application, and then it will deploy that whole application multi-tier in those VMs, okay, in one command, as you can see. So I took a sample and then extended to that. So just kind of give you some of the flexibility that the new features are providing and how we deeply integrate with the Docker ecosystem on the Azure VM. Okay. I'll switch. So deployment is going, because we're provisioning a VM with a Compose. It's probably going to take a couple of minutes, maybe 3 to 4 minutes before it's all done. So I'll let it just go in, so we're not waiting for it to finish. So that was the demo. And so this is great. So we talked about Docker. We talked about some of the capabilities. But this is kind of really the beginning. Azure, as you probably have heard during the bunch of sessions that we've had, it's an open platform. We collaborate with a bunch of our third-party partners to bring those solutions and support them on Azure. And these are some of the examples we have in the kind of the Docker and container ecosystem. We are deeply discussing with Mesosphere, for example, to provide some of the orchestration on how you deploy large type applications and then provide the orchestration behind the scenes, for example. And obviously with the Docker partnership that we've announced several months ago, and then a few others. And today, actually, we have one of the partners here who's going to talk about how you can do monitoring and diagnostics of applications that you deployed. So great, you deploy an application, but you probably want to monitor it and see the health of it. And then if problems happen, how do you actually go and diagnostic? So I'm going to welcome Matthew to the stage, and he's going to give us a little demo on how you do that.
Excellent, thanks. Let's use some moving of machines around. Thank you. 7. One more slide, I think. Cool. Thank you. All right, so my name is Matt Williams. I'm the DevOps evangelist at Datadog. And let's see, yeah. Okay, not the prettiest colors, but so Datadog's a SaaS-based monitoring platform. And basically the idea is you load up an agent on each of your hosts, and we start monitoring. And we collect metrics every second and upload them to Datadog every 15 seconds. And then we keep that stuff for a year. And here's a sample dashboard that we use internally at Datadog. And what's interesting here is not so much what you're looking at, but the fact that some of these metrics are coming from a variety of sources. Some of them are coming from VMs. Some of them are coming from Docker containers. And they're all being aggregated onto one view. One way we do this is through the idea of tags. So we can tag each container or each type of container. Maybe in the example, we had a Redis cache. And so we might assign a tag of role Redis cache or something like that. And then you'd create a dashboard that says only look at the items that have role Redis cache. And you'd see all of the metrics from that, regardless of whether it's from a container or from a virtual machine. We have a lot of integrations. So if you're using Docker containers or VMs or whatever, and then you load up a bunch of applications on top of that, then we're going to be able to plug in right away and start providing you a lot of really great value. And so there's 100 or so things on here. There might be a couple of repeats, but mostly they're all unique. And what I'm going to do now is switch over to a little bit of a demo. I've got just a few minutes, so hopefully this is going to go to the right machine. Excellent. Oh, very different colors there. Anyway, so what I've got here is a dashboard. This is kind of our standard dashboard for Azure. What I can see are number of running virtual machines over the last day, where they happen to be located. Okay, you can't really see that bar graph there, but it's a bar graph. And CPU utilization by day. But we're not on this one, we're not showing the Docker containers. We're just showing the actual virtual machines. You know, virtual machines and containers, they work kind of differently. You know, you're not going to be, you don't really care about individual containers when you're using Docker containers. Usually you're going to care about the overall application. You know, you've got 1,000 containers that are all going towards one application. You don't care about whether Docker container number 1 is doing well or container number 2 goes well. You care about how the overall application is going. You know, one of our customers, a company called Game Changer, they do kind of a youth sports tracking. So, you know, they watch all the Little League baseball games and soccer games, and they do kind of play-by-play tracking. And they use Docker containers, and during the week, not too many kids are playing organized football, and so they only have about 100 containers going. But on the weekends, it scales up to tens of thousands of containers because they're tracking 80,000 amateur games each weekend. And so, again, they don't really care about individual boxes. They just care about the overall application. And so I've got a kind of a different dashboard here. This is looking at number of containers running currently on my Azure account. And basically, I've got 315 containers running. And you see this bar graph down, the second one down. That's showing the number of containers that are currently running right now. And there's actually 3 spikes about half hour ago. This is where I was sitting down here. I thought, okay, it would be really cool if I spin up a bunch of Docker containers. So I go into Docker Machine, do Docker Machine scale Redis cluster equals 400. That was probably a bad idea because it crashed that box. So not a good thing. And then, of course, I put it down and forgot about it. So that's why there was that drop in numbers. But you know, I've scaled up a bunch more. Now I'm at 322. And again, I don't really care about what each container is doing. I just care about the overall application. I'm just going to scroll through some of this. Here I'm looking at CPU system usage by image. Okay, it's a prettier graph on my screen. And what are the most RAM-intensive containers? So that's probably something that's more interesting, not what the individual containers are, but if there is one that's really, really using a lot of CPU, I probably want to know what that is. You know, you can customize these dashboards to look however you like. This happens to be looking at VMs and Redis CPU across all my VMs as well as containers. You can customize this as much as you like. If you want to find out more about us and how we help you manage your Docker containers, we're out on the show floor. I think it's 262 or so, somewhere over that area. And my name is Matt Williams, and you can reach me on Twitter at TechnoEvangelist. So thanks a lot.
All right, thank you, Matthew. And I think we're going to quickly just go over the summary of stuff that we've covered, and then we'll wrap up and switch to questions. So just a quick summary. We went through some of the basics on how you can get started with Docker containers on running on Azure, how to kind of get a Docker host, what does the ecosystem look like, how to evaluate for your application needs, whether containers are the right things to do for you. We touched a little bit on the Windows containers, reference the session. Please go and watch it if you're interested on the Windows containers and some of the demo stuff that they've showed. And then we actually built a real application thanks to Tom. This is great. We're getting some SMS, getting feedback on that. And then how you can actually deploy that application, how you can patch it without a lot of downtime, and how you can actually scale that application. And then we talked about some of the solutions, and we're just scratching the surface here. This opens a lot of stuff on the ecosystem on what we can do, and we've seen how you can, for example, monitor and diagnose your applications using something like Datadog. Thanks, Matthew, for that. So what we'll do now is just open it for questions. But please, there's a bunch of other related sessions on that Madan and Boris has given on Linux in general. There's a bunch of sessions on the Azure resource group that I mentioned earlier. I didn't really dig into it, but there's a lot of great information on that session. Please go and watch it, and you can see how that framework can help you do some of the automation and scale, and then other references that I mentioned about the Windows containers. So open it to Q&A. I think we have a few questions. If you want to ask later, that's fine too. Some of us will be in the booth as well. Just a couple of other references on DevOps. And then please evaluate the sessions, give us feedback. This is a new topic, and we would like to hear from you so we can make it even better in future. Thank you all for joining. And now we'll stay here.